Welcome back to Summarize Science. Today, we're diving into a paper that could change how we teach our AI assistants to be genuinely helpful. Have you ever felt like an AI's answer was technically correct but missed the point, or was just plain hard to read? Well, you're not alone, and researchers are tackling this exact problem. Right now, there are two main ways to fine-tune these large language models after their initial training. The first is RLHF, or reinforcement learning with human feedback, which is like asking a human, which of these two answers is better? As this table shows, it's flexible and covers many topics, but it isn't very precise about why one answer is better. The other method is RLVAR, using verifiable rewards, which is super precise for things like checking a math answer, but it's very narrow in scope. This paper from NVIDIA introduces a new method called RLBFF, designed to be the best of both worlds. Instead of a vague preference or a rigid correct/incorrect, RLBFF breaks feedback down into simple, binary principles. Think of it like a checklist for the AI's response. Is the information accurate? Yes. Does it follow instructions? Yes. Does it have helpful code comments? No. This example here shows how they can take natural language feedback from a person and automatically extract these principles and a simple yes or no. So, the big question is, does it actually work? The results published by the researchers are pretty staggering. They trained AI judges, called reward models, using this new method, and the results are shown here. As you can see in this table, their models, named flexible principles, consistently outperform other models on major industry benchmarks. In fact, their flexible principles GenRM models scored 81.4% on JudgeBench, which put it at #1 on the public leaderboard at the time of publication. But here is where it gets really exciting. The researchers then used their new RLBFF method and their best reward model to fine-tune an existing open-source AI. This table compares their newly trained model against some of the big names in the industry, like OpenAI's O3, Mini, and DeepSeek R1. Amazingly, their model performed just as well, and in some cases, even better than these powerful, proprietary models. Now look at the cost column. Their model is dramatically cheaper to run, costing less than 5% of the cheapest alternative shown. So let's recap the important points here. By breaking down complex human opinions into simple, understandable principles, the RLBFF method allows us to train AIs that are not only high-performing, but also more transparent and controllable. We can specifically tell the AI what aspects of a response we care about, whether it's accuracy, clarity, or conciseness. The biggest takeaway is that this research provides a recipe for creating top-tier AI assistants on par with industry giants, but using open-source models at a tiny fraction of the cost. This could democratize access to powerful AI, allowing more people and smaller companies to build amazing tools without a massive budget. It's a huge step towards more capable, efficient, and understandable AI for everyone. Thanks for watching Summarize Science, and we'll see you in the next one.